All right. As Jason mentioned, this is the circuit breaking and dynamic request routing deep dive Service Mesh Academy. Uh, I am Flynn. I'm a technical evangelist for Linkerd. I kind of thought that maybe I should have called this circuit breaking and dynamic routing the good, the bad, and the ugly, because that's really what we're here to talk about. And candor is one of the core values of the Service Mesh Academy, or at least it would be if we started writing down core values. So with that said, we're going to change things around a little bit in some of this. The first one is I want to talk right now about what you need to do to get properly set up to follow along for the workshop. And the reason for that is that setting up your cluster to be running the whole demo for me takes like 4 or 5 minutes. And that's the kind of thing where I'm not sure we're going to have enough time to do that during the workshop. So I'd like you all to go ahead and do it now. The QR code there will take you to the Service Mesh Academy GitHub repo itself. If you clone that workshop repo and make sure you're using an empty cluster, very, very important, please, please, please do not run this script while you're pointed at your production cluster or anything like that. CD into the dynamic routing and circuit breaking directory, and then run setupdemo.sh. That kind of assumes that you're running this on a cloud provider. At the very end of it, it will tell you what IP address you can go and point browsers to, because you'll need to have some browsers to follow along. If you're using K3D or something local where it's not really going to get a proper load balancer, there's a slightly different way to run that. If you forget the override emissary IP business, it'll still run. It'll just get to the end and complain about nothing really coming up. It's okay. Just point a browser at localhost/spaces and you'll be good to go. And that URL is in the README in that directory as well. Okay, so on the agenda today, like I said, we're doing this a little bit differently. A lot of these we do, we go through and we do a bunch of slides introducing things, and then we go over and do the demo and we're done. This one, we're going to do a few slides, and then we're going to go do the workshop, and then we're going to come back for some more slides, and then we're going to do some more workshop, because it feels like it's going to be a little bit easier to convey what's going on. We have not done this way before, so we would be delighted to hear if that actually works out better, or if people find it confusing, or what. So with that, I'm seeing requests for the workshop channel link again. There's the workshop channel link, slack.linkerd.io, and it's the workshops channel. I'll leave that up for a minute or so until it starts getting in the way. All right. So let's talk a little bit about dynamic request routing. This is a new feature in 2.13. In 2.12 and earlier, we used SMI traffic splits as the primary way of controlling routing within the mesh within Linkerd. And the traffic splits allowed pretty coarse-grained control. So you could look at something and say, right, so traffic going to this service should be split between these two other things, or traffic over here should be routed over through a mirror to another cluster. But that was about it. It was pretty much just you could look at traffic to a particular service, and then you could give it a weighted split. In 2.13, you can route traffic based on lots and lots of other things. The big ones being you can route on HTTP headers, you can route on HTTP verbs, you can do some stuff with gRPC. There's a bunch of stuff you can do in there. You cannot route based on the body, because that gets to be really creepy really quickly. And it also has a lot of fascinating and troubling performance implications. But you end up able to do a whole lot of stuff based on the headers and the verbs and things like that. Some big ones. You can do progressive delivery directly with Linkerd anywhere in the call graph, whether your Ingress controller can see that or not. We'll be showing that. You can do an A/B test where and we'll show that again, I'll explain in a minute, but we can do an A/B test, again, anywhere in the call graph, and that gives you a whole lot of power. You can do things like, you can combine the two, do a canary based on only for certain users. There's a ton of different ways you can mix and match this stuff. There's a lot of flexibility in there. This is configured using the new Gateway API HTTP route resource. We picked this up in Linkerd 2.12 to do route-based authentication, and some of y'all will probably remember that being discussed in an earlier SMA. We have added support for certain things within the Gateway API HTTP route to be able to do dynamic request routing. The biggest one is that we honor the parent ref section. So we added things that we honor with parent refs, so that in addition to being able to specify a parent ref that is a server in Linkerd, you can also associate it with a service. And that's how you can configure, hey, traffic going here, I want to do something with it. We also added the ability to support backend refs. So the backend refs in an HTTP route now give you control over where traffic to a given service goes. Quick question I see about gRPC route. gRPC route is not currently supported. It's on the roadmap. We know we need to do that. And as long as I'm looking at questions, dynamic routing using the pod IP via header request. If you put the pod IP, if you have a header with a pod name in it, you can route based on it. Yes. I'm not sure that made a lot of sense as an answer, but
is it fair to say, Flynn, that you can make routing decisions based on anything in the header?
Yep.
Awesome.
Yeah. And of course, you can always have lots of fun with applications injecting headers at various points in the call graph and then make routing decisions on them and things like that, right? All right. So this is probably a good time to talk about the Gateway API itself. If you are somehow not familiar with the Gateway API, which would only be surprising if you'd been following along with Linkerd, it is a project within Kubernetes SIG networking. It got started in 2020 and was primarily focused in the beginning about doing something about the fact that the Ingress resource had pretty much just become the wild, wild west, with everybody throwing annotations on it and no two implementers supporting the same annotations. This was a problem. At this point, the Gateway API has gone from alpha stuff up through just releasing their version 0.7.0. Gateway API's goal is to reach 1.0.0 this year and go GA, at which point we would expect that Kubernetes providers just include the Gateway API when you bring up a Kubernetes cluster. And another part of that path is this Gamma initiative, which was started last year with the explicit purpose of sorting out how to use the Gateway API for service meshes. There are some things about the Gateway API that are really straightforward when you apply them to service mesh use cases, I should say. There are other things that are really not straightforward, and that's the whole purpose of Gamma. Linkerd has been very, very active with the Gamma initiative. I personally end up spending a fair amount of my time dealing with Gamma and the Gateway API and trying to make sure that we're steering those in directions that are helpful for Linkerd and for the Kubernetes community as a whole. So these are good things. Linkerd picked up the Gateway API back in 2.12 when we started using it for per route authentication and authorization. The goal is that Linkerd wants to be using the Gateway API as the primary vehicle for how we talk about classes of HTTP traffic, how we manage that. That very much includes gRPC. Sorry, I just got my attention just got stolen because I can see the chat. I think I should do something about that. SMI is still focused on Gamma. SMI is completely independent from Gamma, and it is important to us within Gamma that Gamma should be able to express all of the things that SMI is currently able to express and more. There are places where it makes sense to really directly borrow concepts from SMI, and there are other places where it makes much more sense to kind of use it as an example of prior art as we think about ways of doing similar things. So two different things, but yeah, we're paying attention to SMI in Gamma. Things that we like in the Gateway API: it is powerful, it's flexible, there's a good path to having it just included in Kubernetes by default. We also kind of like the fact that Linkerd doesn't have to maintain all the CRDs all by ourselves. It will be nice to have more things within Linkerd that you can express using standard resources rather than having to learn the Linkerd custom resources. There are also, of course, some things that we are very actively working on within Gamma and the Gateway API to try to improve the situation. The biggest one is that there are a lot of things you just cannot yet do within the Gateway API. A great example of this is retries. You cannot currently configure retries in any standardized way using the Gateway API. And retries are obviously kind of important. So this is an area where we need to figure out how to drive this back forward so that this becomes something that makes sense within Gateway API. We also need to figure out, because getting things through the Gateway API is a longer process than doing a Linkerd release. And so we have to figure out how we're going to express these things kind of around the Gateway API before they've been fully standardized. So there's a lot of work going on very actively in those areas. Another thing that is a thing we're working on actively is that we currently cannot pass the Gateway API conformance tests to say that we are a conformant implementation. The biggest reason for this is that the Gateway API tests assume that you are an Ingress controller because they were originally designed looking at that north-south routing problem. Linkerd is not an Ingress controller, so there's no way we can pass that. This is the biggest reasons why we currently are using HTTP route, for example, is in the policy.linkerd.io API group so that we have a better answer around sidestepping some of the conformance stuff. Now, this is all changing very quickly. The Gateway API has just, like, in the last, I want to say the last few weeks, few months, introduced and started formalizing the idea of conformance profiles, where we can have a mesh conformance profile. And so that opens the door to Linkerd being compliant with the mesh profile within Gateway API. And that's something we're really interested in doing. So all of this is changing very quickly, and we will be talking about all of this at various points in the future as things change and become relevant. All right, Jason, do we have any questions that we need to tackle before we get away from the Gateway API and Gamma?
No, I think you're good.
Awesome. Okay. That leads us into circuit breaking.
Just before you go too far, folks, if you are asking questions, you can continue to ask in the chat on wherever you're watching this directly. Or if you want it to be, if you want to have more nuanced conversations, you can come over to the Linkerd Slack, slack.linkerd.io, join our workshops channel, and we can talk with you about stuff there. Sorry, go ahead, Flynn.
Overall, the Slack is the better way because it permits more conversation and permits us staying in touch. All right,
Yeah.
breaking. Circuit breaking is a very, very new feature that has been requested for a very long time. And the basic point of circuit breaking is, if you have a failing endpoint for a workload, perhaps you should not continue hammering it with more traffic. Perhaps instead, you should stop delivering things to that failing endpoint so that it has a chance to recover. And then after a little while, try it again. And if that works out okay, then you can slowly start feeding traffic back to it. We talk about opening the circuit breaker when we stop delivering requests because there have been too many failures. And we talk about closing the circuit breaker when we restart issuing requests to the thing. In 2.13, we kind of have a limited implementation of this. The first thing here is we will only open breakers when we've seen too many consecutive requests. So for example, or too many consecutive failed requests, excuse me. So for example, we don't currently support opening the circuit breaker when the percentage of successful requests drops too low. And that's something that should definitely be possible and can be really useful. But we decided to start with something small so that we could get feedback on it. Failure to circuit breakers right now means HTTP 5 series responses. So 4 series responses can come back all the time, but we won't open the circuit breaker for those. The reason is that a 4 series response is supposed to be telling the client that they've done something wrong and can retry. So shutting down the endpoint of the workload when the client is doing something wrong doesn't really make a lot of sense. On the roadmap is being able to configure which responses are considered failures and which are not, but we can't do that just yet. My personal favorite in terms of limited implementations is that you currently configure circuit breakers by putting annotations on a service. Annotations don't delight me, I'm not going to lie. On the other hand, they are a wonderful, wonderful way to quickly do something so that you can get feedback over whether the functionality is a good thing or whether it's not what people want and need. That's why we decided to go that route, is so y'all can start using it and tell us what works and what doesn't. We do not intend to do a hard switch away from annotations. As we come up with other mechanisms of doing this, we will still support annotations for a good long time so that you've got a nice migration path. So don't panic about that. Full documentation is right there in the web browser. Tasks/circuit breakers in the docs. I would encourage you to go check that out, and I would encourage you to provide feedback on the docs too. And again, there's a lot of work coming in future releases for circuit breakers. Okay. This is what the annotations currently looks like. They are all under, well, they all appear to be under the balancer.linkerd.io group. Annotations don't really have groups, but we can make them look that way. And you will also notice that they all say failure accrual in the name. And the reason is that internally, failure accrual is the mechanism that we are using, and it's a little bit broader. And yeah, I'm not going to lie. I probably would have preferred that we call them circuit breaker, but it's okay. I get it. So the first thing here is setting up to break a circuit after 4 consecutive request failures. You would first say failure accrual : consecutive to activate the consecutive failures mode. This is currently the only mode, but it's not going to be the only mode for long. And then after that, you would use the failure accrual consecutive max failures annotation to say how many failures you want to allow before you open the circuit breaker. The next one, consecutive min penalty, sets the minimum time after the breaker opens that it must remain open. In this case, we'd be setting it to 30 seconds. That is the minimum time. It will grow exponentially as we occasionally retry. If it keeps failing, we'll back off longer and longer until eventually we hit the consecutive max penalty time. In this case, I'm showing that set to 2 minutes. So the way this would work would be the breaker would open. 30 seconds later, we would try one request. We would allow one request from the client through to that endpoint. If it continues failing, the next time we will wait a longer period of time before we try another one. We'll cap that wait at 120 seconds in this example. One important thing to point out here that I didn't really write on the slide is that request to see if your workload endpoint is working is a real application request that came from a real user. So that may be visible to them. And that's something you might want to think about. It's also something that we would, again, love to hear feedback about. Okay, I think that is it for circuit breaking slides. Do we have any questions that we need to talk about?
So Chad's asking, and it's already been answered, but how does circuit breaker differ from downstream services and fail fast that happens today?
Yeah, they're pretty different. The short version, I think, is that circuit breakers are intended to give you more control over when exactly the thing gets closed off. And fail fast is more of a lower level. Nothing is talking to us at all, so we're not going to try for a little while. What do you think on that one, Jason? How would you put that?
I think that's a solid one. I also liked Alejandro's answer, right? So
Yeah.
Alejandro just said that, the circuit breaker config would basically catch the errors and, time out
Do
the
something about
pod.
it. Yeah.
Whereas fail fast would just be, hey, there's no one that's going to serve this, so this request
Right.
isn't going to get processed.
Alejandro also makes the point that circuit breaking is kind of a superset of fail fast. So the errors that fail fast would get triggered by should be things that the circuit breaker would get triggered by. And so maybe you'll be able to keep that endpoint out of fail fast anyway. That's a maybe. I think I'm gonna have to go test some of this later. Okay. Anything else?
No, I think that's
I think that's
the
it. All right, awesome. Okay, we're going to talk really briefly about the architecture of the demo we're going to use. This should be familiar to many of you by now, I think. We're doing this with the world famous Faces demo. Maybe it's world famous, I don't know. We have a GUI, which is a single page web app. It talks into the face service in our cluster. That one talks in turn to Smiley and to Color. Smiley should be returning a grinning face. Color should be returning the color green. The face workload will composite both of those together, and the Faces GUI will do this in a cell or in a grid of cells over and over and over again, and we'll see the results. In many situations, when I work with the face demo, it is deliberately configured to not actually behave this way, but in this case, we are going to configure it so that it should be working. We also have in the cluster a Smiley 2 workload, which returns a hard-eyed face, and a Color 2 workload, which returns the color blue, but at the beginning, nobody's talking to them. Under the hood a little bit, we're using emissary ingress to mediate access from outside the cluster to inside the cluster, could be anything. And of course, Linkerd is mediating communications everywhere inside the cluster, including the Smiley 2 and Color 2 services that we're not talking to yet. All right, so with that said, let us see if the demo gods are going to be smiling upon us today. This will be interesting, as it always is. All right, so we're going to talk about dynamic request routing and circuit breaking. We're going to demo both of those here. You can follow along by looking at the README in the repo that you got pointed to earlier. We are going to start with dynamic request routing. So there we see the Faces app in all its glory, sort of. And you can see that, yeah, we see a bunch of grinning faces on green backgrounds, which is what we want. We can apply an HTTP route and start changing some of that so that we get different behaviors. In this particular case, what I'm going to do is I'm going to use an HTTP route to start slowly shifting traffic away from the color workload to the color 2 workload. And you'll be able to see that visually in this grid. So here's my HTTP route. Its name is Color Canary. It is in the Faces namespace. This is important. If you're trying to mess with stuff going to a service named Faces in the Faces namespace, you put the HTTP route in the Faces namespace as well. We are, in fact, intending this HTTP route to be bound to a service whose name is Color. This is a core Kubernetes resource. We also specify the port. And the reason for this is that services can talk about multiple different ports, and we need to tell the HTTP route which port is relevant. One really important caveat here, you need to use the services version of the port number. So if you were to go look at the deployment, you would find that the Canary service actually binds to port, it's either 8000 or 8080, I don't quite remember. If we tried to say port 8080 here, it would not work because that's not the port for traffic going to this service. Traffic going to the service is addressed to port 80. We will come back to that later in this demo. What we're going to do then is 90% of this traffic will continue on to the thing behind the real color service on port 80, and the other 10% will continue on to what's behind the color 2 service on port 80. And again, these are service port numbers. They are not the pod's port numbers. So when I apply this, we should immediately start seeing a change. I shall leave 10% of 16 as an exercise for the reader, or the viewer, I should say, but you can see that, yeah, we get some blue faces or some blue backgrounds pretty immediately. So far, so good. The other thing I should probably point out is that these weights, there's no requirement that they add up to 100. I could have used a weight of 9 and 1 or 9,000 and 1,000, and it would still work. I personally kind of like to express them as percentages just because it tends to make it a little bit easier to reason about and a little bit easier to talk to other people about it. So let's go back and take a quick look at the demo architecture again to get a little bit better sense of what exactly is happening here. What's happening here is pretty simple. is we've got the face. When we started, everything from the face service to color would go over here to the color workload. What we're doing right now is literally just siphoning off some of that to go over to color 2. And I cleverly did that exactly the wrong way. Yeah, there we go. Color 2. Everybody can see that dashed line, right? Okay. So once this is happening, we can also, there we go. We can change the weights and we can change the behavior. We don't need to reapply. We could do this by kubectl edit. I'm going to do it with kubectl apply. We don't need to delete the route and then reapply it. We don't need to edit the application. Well, all we really need to do is apply a new HTTP route in this case, where the only differences that I'm doing here are I'm changing the weight on the color backend from 90 to 50, and I'm changing the weight on the color 2 backend from 10 to 50. So after applying this, we should end up with a 50-50 split. And again, that should happen immediately. We should not need to start waiting around for a lot of time. Also, just to be clear, a certain amount of the selection of backend endpoints is random. So when we say 50-50 or 90-10 or whatever, yeah, there's a stochastic process happening there. You're not usually going to always see exactly 50% of one and 50% of the other. But as we watch this change, we can see that overall, it's, 50-50-ish over time, right? Continuing on, if we decide at some point that we're happy with that and we want everything to be blue, we could do that by deleting a backend ref, but I wanted to show you in particular that we can also do it by just setting a weight to 0. And that's kind of relevant because it can be easier to patch these than to go through and delete things. So here I've set the weight from 50 to 0 on this one. Color 2 goes from 50 to 100. Honestly, all I really needed to do was set the weight on color to 0, because then any weight at all on color 2 will take all of the traffic. But if we do that, then in short order, we should see only blue backgrounds across the entire grid. There we go. So this is one of the basic things you can do with dynamic request routing. This is progressive delivery. You start off with all your traffic going to one workload, you bring in a new version of it, and then you gradually shift traffic over to it, which gives you an opportunity to make sure that things are working while you're shifting the traffic around. Any questions with that so far?
I'm not seeing any. So if you're, I have one though. If you're using a progressive delivery tool like Flagger or Argo rollouts, are we using these HP routes today?
Sadly, no. And the reason for that goes back to that conformance issue I mentioned, where we're actually using an HTTP route in policy.linkerd.io. Flagger has a mode that works with Gateway API and uses HTTP routes for exactly this purpose. But they require that you be using the upstream Gateway API HTTP route, and they won't work with the linkerd.policy.io version of it. This is another reason why we want to go ahead and get to conformance and switch to using the upstream group, because then a bunch of stuff like this becomes possible. For right now, though, if you want to use Flagger with Linkerd, you are still going to have to use the SMI traffic split route, which Flagger does support. But yeah, future work, definitely a thing we want to do.
So don't throw away your SMI extension just yet.
Not just yet.
Okay.
Maybe next week.
Do you know anyone involved with Gamma that we could talk to about this?
One or two people. A couple of them. In all seriousness, the conformance policy part, conformance profile part of Gateway API, we saw a pretty cool demo of that earlier this week, and I'm feeling pretty good about that. Really, I'm feeling pretty good about being able to use that soon to be able to address some of these issues. Soon is really not next week. That was a joke, but it's probably not very many weeks out in the future. All right.
So we do actually now have a bunch of really good questions over in Slack.
Okay.
The first one's already been answered by Alejandro, it looks like. So Joaquin asks if we have both gRPC and HTTP, what do we use?
I would use HTTP routes, and the problem here is that I no longer remember exactly the details here, but gRPC is, wow. Really, I can speak English, I promise. Okay, gRPC is a protocol built on top of HTTP2, and all of the things in gRPC, like the provider and the service, actually get mapped to HTTP paths. So you can use HTTP routes if you set the path on the route correctly and use it to split gRPC stuff. A little bit interesting. I would probably need to go do some checking on that one, Jason. We should probably put that on our list of things to actually, really solidly test. But yeah, that's the way I'd start out approaching it. So hopefully that answers that question.
Yeah, of course, it all depends what exactly you're trying to do,
Yeah.
right? If you just want, again, if you just want traffic splitting and you're using something like Argo rollouts or Flagger today, right? Continue to use the SMI today because that's going to be the easiest path forward, right? Although expect before too long that all of that work is going to shift likely from SMI to HTTP routes or those gateway API objects.
Hmm. I see Joaquin's comment about dgraph, which actually looks kind of fun to play with. So that's cool.
We have another really good one from Chad about, basically different deployments and doing it on a header basis. And I don't know, Flynn, if you have any objections, but I was going to suggest that we just delay that until you get to that part of the demo. Because
Yeah,
spoilers,
yeah.
Chad, he's going to get to a conversation that's very much on that topic.
That's the next piece. Yeah. Do we have anything else? Uh-oh, Joaquin just volunteered to help test. You have no idea how much trouble you're about to get into, Joaquin.
We have a great
Uh,
one from Miad about like the migration path if you're using a tool, right? And then the just a quick answer, yeah, right? Like it would be those are more things that'll be able to be addressed at the time when the time comes. But both Flagger and Argo rollouts today can handle either SMI based rollouts or progressive delivery, and they can also handle Gateway API progressive delivery. So you're essentially going to change the type in your custom object in your tool, right? But Linkerd continues to Linkerd for now does both our HTTP route and HTTP route based changes as well as the SMI.
right. Um, to add a little bit to that, if you want to go and switch Argo or Flagger to use HTTP route splits, yes, you're going to need to wait for a version of Linkerd that fully supports the upstream real gateway API version, which hopefully is not that far off. So everybody cross your fingers. Okay, let's go ahead and look at the next topic here, which is A/B testing, which I think is pretty much what Chad was asking about. So what we're going to do here is we have two browsers going. One of our browsers is going to send this xfaces header test user header, and the other one is not. And then we're going to use that header to switch what's happening in the call graph at different points. So here's our normal one, and you can see that it says user unknown, meaning it's not sending the xfaces header. Wow, that's a typo. It's actually the xfaces user header. All right, got to fix that. The other browser that we're going to do is using mod header. And on this one, you can see that it says user test user. So it is sending this header with a value of test user. Okay, so now those where it says normal user and test user, those are windows onto the real browsers. So everything that I just said about the browsers is still true here. So I'm going to add this HTTP route named Smiley AB, which should give you a hint as to what workload we're going to be A/B testing here. Once again, got to be the faces namespace. Once again, we're talking about this. Well, we're talking about the Smiley service, and once again, we have to use the services port number. But this time, rather than just having two backend refs, one of our backend refs has a matches clause. So it's saying, if you have a header named xfacesuser and its value is exactly test user, this matches, and we will send all of the traffic that matches to the Smiley2 service, not the Smiley service. Everything else, since there is no matches clause in this backend ref, it will go up to, or continue on to the normal, whatever's behind the normal Smiley service. One thing I'm going to point out before I apply this one is headers in HTTP2 are always lowercased. So this name is lowercased, even though I referred to it with proper header casing earlier. The value I'm actually sending in all lowercase. So with an exact match, you do have to pay attention to that. All right. So as soon as I apply this one, we should immediately see the test user getting hard-eyed smileys from the Smiley2 workload. And we do. Always nice when the demo gods smile upon us. And again, the thing that I keep wanting to emphasize about this one is the application doesn't know anything is going on here in the mesh, right? The application is just going off and doing its thing, and we're completely changing what it does by tweaking the mesh underneath it. There's one other thing that's important to note here, which is that the browser is the thing that's setting that header, xfacesuser. And so we go from the SPA into the face workload into the Smiley workload. And that means if you are trying to do A/B testing with a header, your application needs to propagate that header through the call graph to the place that you need to make decisions based on it. So if you want to do A/B testing based on a header deep in the call graph, you have to make sure that the header that you're using for the A/B test makes it all the way down into the call graph. That's the only place where you should need to worry about this in terms of how you're structuring your application. Now, once we're happy that the users like the hard-eyed smileys, and we want to make everything hard-eyed, there are a couple of ways we could do that, but the simplest one really is just to delete that backend ref with the match. So now the only backend ref we have is saying, go to Smiley2, with the result that everything that used to be going to the Smiley service is now going to get diverted off to the pods behind the Smiley2 service. And if we do that, then we will see that everybody is getting hard-eyed smileys now. This is the point where William usually makes fun of me and says, you can tell it's a Flynn demo because it's all hard-eyed smileys instead of like the poop emoji or something. So any questions about this?
So far, folks seem to be fairly happy with it. So we'll give it a bit. Folks, if you do have questions, post them in, and Flynn will either try and answer them directly, or one of the Linkerd folks will respond to you in Slack.
Yep. We will shortly get to why I've been trying to be careful to say traffic to a service gets routed to the things behind this other service. I'm sure I've slipped up sometimes, but that's actually an important concept, which we will be talking about in a minute. The other thing that's worth pointing out is, like I said, there are ways you can do this A/B test and still keep both of the backend refs around. Should you want to do that, you could, it's just more straightforward to me to go ahead in the A/B test. It's more straightforward to delete the one you don't want. Another question that I'll bring up, because people have asked it once or twice out of band, is why would you do that instead of just changing the deployment behind the Smiley service so that everything is doing hard eyes? And the answer is, realistically, you would probably do that at the first opportunity you get. But what you might want to do is use this mechanism to unconditionally route traffic, just to go ahead and cover the situation before you get around to changing the deployment, and also to arrange it so that while you're changing the deployment out, you don't have some people who are still getting the old version when you really want them to get the new version. Does that make sense? Hopefully.
Yeah, it does. And it's where, again, if you're out there, if you're using a progressive delivery tool, that's where they shine, right? Because they're going to
Oh
be
yeah,
able to shift your traffic around and scale up and change your deployments behind the scenes.
yeah. There's Joaquin, I think it was, who mentioned the blog post that just went up about the GitOps deep dive, and I'm not gonna lie, doing that blog post and doing the workshop it was based on really demonstrated some pretty impressive stuff on the GitOps tool front. It was kind of cool. Okay, let's go on to circuit breaking. Remember, the point here is that we're going to stop sending traffic to particular endpoints when they start failing. So in order to demo this one, the first thing we're going to do is we're going to come over here to our browser and click the Show Pods button, which will put up another little chunk. Wait, first it would help if I went to the correct browser, wouldn't it? So we're going to come up here and hit the Show Pods button in the actual browser that I'm showing. And now we can see which pods are giving us responses kind of separately from the grid that shows us what all the responses are. So at this moment, we have 2 face deployment pods. They're giving us all the answers, and they're always giving us hard-eyed grinning faces, which is kind of nice. So having done that, the next thing we're going to do is we're going to add 2 more pods behind the face service. I'm doing this in kind of a weird way. I'm adding a new deployment called phase 2. And the reason is that I want to be able to change environment variables and things like that on that deployment. But I have deliberately used the label selectors that match the face service. So even though I have 2 different deployments, the end result is that we're going to end up with just 4 pods running behind the single face service. Hopefully that makes sense to everybody. As this spins up, there we go. Now we see all 4 of them. The big thing that's different between the face pods and the phase 2 pods is that the phase 2 pods can get stuck in this error state where the only thing they will ever do is return an HTTP 599 error code, which the browser will display as this meh face on a pink background. We do not want meh faces. We want hard-eyed smileys. That's all we want. Meh faces are no fun. So now that we are in a state where there are clearly lots of failures happen, we can go on and look at breaking the services here. So we're going to apply 3 annotations, all with one kubectl annotate command, and we're going to apply those to the face service itself. We're going to turn on the, do circuit breaking when you see too many consecutive failures. We're going to set the number of consecutive failures to 30, which seems like a very high number, but will happen really pretty quickly. And we're also going to say that once a circuit gets broken, once a circuit breaker opens, it will stay open for at least 10 seconds. Before I do this, I want to call your attention to one other thing here. By pod, it's a 50-50 split between working pods and non-working pods. But if you look at the grid, most of the time we have more meh faces than we do hard-eyed smileys on a blue background. The reason for that is that Linkerd tends to prefer endpoints that respond quickly over endpoints that don't. And the way this particular demo is written, the failing pods end up responding faster on average than the non-failing pods. So if you're curious about why that split seems to be weighted towards badness, that's why. So let's do this. And as we sit here and watch, if you look at these little counters, those are the number of consecutive failures. So very shortly, if the demo gods are smiling upon us, they should have ratcheted up by another 30, and we should see those pods fall out of the mix. There's one, there's the other, and now we all have hard-eyed smileys on blue backgrounds again. It's always nice when the demo gods smile. You also got to see one pop up there, right? So this is where Linkerd, 10 seconds have gone by, Linkerd decided to pass through a request and see if it worked. This demo is not always great about showing that in the grid for various reasons, but you'll see it in there. And you can see that it's now taking longer. We just said about that. Eventually, the phase 2 pods should be able to recover and start doing traffic again for a little while successfully. We're not actually going to wait around for that to happen. We're going to keep going. But yeah, there you go. There's circuit breaking. Okay. With that, any other questions before we go back and we talk about some of the gotchas?
We do have some more questions, but we're going to get a little bit more clarification before I bring that up. So why don't you hop into the
All right.
gotchas and then we'll ask you some more questions.
Let's talk about gotchas. The biggest single gotcha in any of this stuff is that service profiles do not compose with these shiny new features. Specifically, what that means is that if you have a service profile and you define routes in that service profile, that will win over HTTP routes on this, for the same paths, and over circuit breakers for workloads that the service profile is using. And this is going to be the case for the foreseeable future, because when we sat down and we thought about it, there were too many bad ways in which having the HTTP route win could really surprise people who were doing upgrades. So the reason that this is a challenge is that there are still several things in 2.13 that you need to do with service profiles like retries and timeouts that you cannot yet do with HTTP routes. And that makes it more challenging than we would like to go through and adopt all the shiny new things. We are very actively working on making this better. This is a major focus of work happening right now, so don't panic. This will not be the case forever. The goal here is to arrange it quickly so that you can get away from service profiles over to HTTP routes. For right now, let's talk a little bit about debugging, though. The biggest one here, and for the record, I ran across these things while I was putting this demo together. So these are tried and true ways of helping debug. The first one is look to see if you have any service profiles. If you're setting up from a green field, you probably won't. But if you're setting up something where you're running an existing staging setup or an existing development setup, yeah, you may actually have staging workload, or you may already have service profiles in play, and you may need to delete the service profiles before the HTTP routes will start taking effect. One extra gotcha there is that if you do have service profiles and you remove them, you might actually need to restart the pods that are feeding traffic to the things that the service profile affected. Glossing over lots of things, internally, the proxy on the workload that's sending traffic to the place you're going to do circuit breaking, that kind of needs to decide what mode it's operating in, whether it's going to look at service profiles, whether it's going to look at HTTP routes. And there are a couple of cases where it won't switch cleanly, so you might need to restart them. There's a new command, Linkerd diagnostics policy, that can show you some things that will help you debug this. And we're going to switch over right now and take a look at that just to see what it kind of looks like. So the new Linkerd diagnostics policy command. In this case, we're telling it that we want it to look at the smiley service in the faces namespace for traffic on port 80. And it is going to spit out a bunch of stuff, like a bunch. So here we go. Couple of critical things that you can look for in this, though. It tells you what service it thinks you're talking about. Always nice to make sure you got the right thing. It also starts showing you HTTP routes that are bound to that service. Also a really nice thing. And if you keep scrolling down, you will be able to find, hey, look, everything is going to Smiley too. Since that is the only backend being mentioned, you know that that's everything going through there. You can also see, this is a little hard to see, but this matches clause belongs to that backend on line 22, where it's basically saying, yeah, we match everything here. Prefix match on /, go for it. You'll see HTTP 2 and HTTP 1.1 separate, 1.1 separately. In this case, they're going to show us the same information, so that's also kind of nice. There's, this is very verbose. There's a lot in there. I have not yet really spent a lot of time trying to play with JQ or YQ to go through and figure out useful ways to pull some of this out. It's on my list, but it's already at a point where it can show you a bunch of useful things. To contrast the smiley service, let's now go and put that 50-50 canary back in. And if I flip back to this view, you can see we've got roughly half and half green again, right? So we know that went into effect. And we can then come back here and we can look at the policy for the color service on port 80 in the faces namespace. And if we do that, we will see that we've got one path to color with a weight of 50, and then we've got a separate one to color 2 with a weight of 50. And also I realized I said the wrong thing earlier. That matches clause goes with the rules up here. Never mind. Okay. So you can actually see how the routes are being put together, and you can see traffic splits in this fashion. You can also see traffic splits by, going to things like Linkerd Viz and looking at them that way, right? Now, there's not a really cool Linkerd diagnostics command yet for circuit breakers, but we can use Linkerd Viz stat to infer some things about the circuit breakers that end up being useful. So if we use Linkerd Viz stat deployment, all we see is it's taking about 6 requests per second, and it has a 100% success rate. But if we look at the pods that are associated with the service equals face label, then here we can go through and see, oh, hey, look, these two are taking about 3 requests per second apiece, and these two are being largely ignored. And so that can be a really useful diagnostic tool for helping see what's going on with circuit breakers as well. Any questions on that so far? Or questions we ought to get back to?
So Miad asked the question about basically adding timeouts and retries to HTTP route, right? So, about what's happening with service profiles and how is that going to relate there?
That is the plan. We are actively working on both. We're actively working both on sorting out with the Gamma group and the Gateway API group how to get timeouts and retries as standards in the Gateway API, and on how we want to support those with HTTP routes in Linkerd in the short term, with a good path to supporting them as they become standard. Until then, you're pretty limited on what you can do with timeouts, retries, and circuit breaking all at the same time, which makes me sad, but yeah.
So to answer your question, I think a bit more briefly, yes, there is a plan to add timeouts and retries to HTTP route.
Yeah, and we expect that to be pretty quick.
But yes, in the interim, you're at an either or.
Right.
Is that true for circuit breaking also, or is it just for the header-based routing?
It turns out to be true for circuit breaking too. Okay. Anything else that we wanted to cover?
That looks pretty good. I think we've answered all the questions.
Awesome. Okay. So, oh yeah, sorry, I should have mentioned that before flipping away from that window. If you try to just watch Linkerd stat right after you apply a circuit breaking annotation, Linkerd Viz stat is kind of a lagging indicator. It averages over a relatively long window in terms of, when you compare it to the kind of time that applying a circuit breaker can take. So give it a few minutes and watch before you start freaking out about how circuit breaking isn't working. Okay. Here's another gotcha that I wanted to cover. which is that HTTP routes don't stack. So if you try to set this up where you've got a 50-50 split for traffic to foo between foo and bar, and then you want to do a 50-50 split between traffic to bar between bar and baz, then if you feed traffic directly into the bar service, it will get properly split between bar and baz, which is good. But if you feed it into the foo service, you're never going to see it make its way to baz. And the reason for that is a little complex. There's actually a distinction between what Gamma has taken to calling the front end of a service and the back end of a service. The front end of the service is the cluster IP that has a name associated with it. The back end is the endpoint IPs that are connected to pods. And routing only happens at the front end of a service. This is why we talk about HTTP routes being associated to a service and then sending traffic to the things behind that service. So when the front end, in this case, like the blue one labeled foo, makes a routing decision, it will go immediately to a back end, and it will not go instead to another service front end. That's why you end up seeing a split between foo. Traffic to foo can get split between foo and bar, but you won't see it doing a two-level thing. Really what's happening is that when you were trying to set up this, you actually set up something that looks a lot more like this. And that is another good one that could potentially be confusing. I think that's it for the gotchas. That is it for the gotchas. Questions, comments, heckling?
No heckling that I'm aware of. The questions seem to be pretty well answered.
Cool. Anything that came up on your mind, Jason?
No, this was really
Anything on the
informative
spot?
and interesting. Thank you.
Cool. All right.
So if people enjoyed this and they want more, Flynn, where do they go?
We will get to that in just a moment. And in fact, I'm going to go through and do some of these. Chad says the last gotcha is confusing. All right, I'll try to figure out how to explain some of that better. The takeaway is don't try to stack the routes. So, don't try to have a split that feeds into another split that that sort of thing. Okay. Some housekeeping kind of stuff while we wait to make sure there are no more questions. We do the Service Mesh Academy pretty much every month. The next one is on June 15th, where we will be revisiting the Linkerd in Production 101 topic, having updated it especially for 2.13. That QR code will take you to the URL next to it, buoyant.io/SMA. Love to see you there. Let's see. We also have the new Linkerd forum. This is a really nice place to go through and try to either give feedback or get answers. Things that you say on the forum will not be thrown away like they will be on the Linkerd Slack. So please, please, please come to the forum and join us there. We also have a new Fundamentals of the Service Mesh course. You can get a certification at the end of it. We mentioned that earlier. I think you go to learn.buoyant.io, which is at that QR code on your screen right there. I'm actually going to back up a minute here to give people another chance to snapshot QR codes or whatever. There's the Service Mesh Academy. Here's the QR code for the Linkerd forum, which is linkerd.buoyant.io. Here's the QR code for the Service Mesh course and certification, which is learn.buoyant.io. Lots of things.buoyant.io. And of course, buoyant.io/demo. I can't believe we don't have a QR code for this one. Is where you can go to learn about fully managed Linkerd on an Kubernetes cluster, which is pretty cool, actually. Okay.
So Chad asked a clarifying question.
A backend service that's split two, and then that backend service itself calls another service that has a split associated. So I really hate to say this. It depends. Most of the time, when you're writing, so I'll pick on the face service, and yeah, I'll pick on face and color and smiley. The way face calls the smiley service is it literally opens a connection to smiley.faces.service.cluster.local is the fully qualified name. So it actually does a DNS query within the Kubernetes cluster. That will be routed, that DNS query resolves to the front end of the color service or the smiley service. And if I put a split on color or smiley, it will take effect and it will happen. If I had written face for some completely insane reason to go and query the endpoints for the face service directly and then try to speak directly to an endpoint, the split would not happen, in much the same way that if you do that with a service today, right this very second, most of Linkerd's advanced stuff like advanced load balancing and some metrics things are not going to happen in that case either. So the moral of that story is, if you want to take full advantage of your service mesh, have your workloads call each other just using the name of the service so that they do go through the whole front end of the service and we get to do all the advanced stuff we want. Hopefully that made sense. I think I'm going to stop sharing this screen for the moment, actually, while we see if there's anything else.
Yep, Flynn, that was really helpful. Thank you.
Cool. Hopefully some other folks think it was helpful too. Chad says we do that. Awesome.
Always and another nice. Thank you. So I think that's a good sign.
Yeah. Hey,
I see a bunch of them.
It is very interesting to try to go through and break down a bunch of this stuff and try to both cover the functionality that's being added as well as the gotchas for the functionality and what we plan to do about them. So feedback on the gotchas, feedback on how well it works for you in its current state and what you'd like to see to make it work better. All of that stuff is wonderful to hear and very important for us.
What's a great place if you do have a particular feature that you're requesting out of Linkerd and you're in the open source community? What's your best pathway?
Opening an issue in the Linkerd 2 repo is probably best. Well, I guess it depends on best, right? Bringing it to us on Slack to, if you have questions, you're not 100% certain about how to phrase your issue, how to approach it, what sort of reaction it's going to get, all that stuff, then bringing that to us on Slack or on the forums, brilliant way to do that. I probably recommend the forums a little bit, although Slack is probably better for just, quick questions where you just want to ping somebody really quickly, get a quick answer, and it's not important that it linger around for a long time. See another question, major differences between Cilium Service Mesh and Linkerd. There are several of them, but the biggest ones I want to bring up are, first, Cilium. It's important to differentiate between Cilium, the CNI, the container network interface implementation, and Cilium, the service mesh. Cilium CNI, we think is great. Linkerd works very nicely with Cilium CNI. We think it's a good tool. We think it's very mature. We think it's really stable. We like it a lot. Cilium, the service mesh, is very new, and we do not think that it's that mature yet, simply because it hasn't had time to gain that maturity. So Linkerd is a much, much more mature service mesh than Cilium service mesh is. Linkerd is also much more operationally simple. There are a lot of things with Cilium service mesh where you're likely going to end up needing to go and do operations at the node level and pay attention to that kind of stuff and do some manual balancing of things across nodes, and you're almost certainly not going to have to do that with Linkerd. So those are the two biggest things there. Awesome. Hopefully that answers the question. This is, of course, the point where anybody from Cilium anybody from Isovalent who's snuck onto the call is sitting here cursing my name or something. I don't know.
Well, they should be doing it in the workshops channel on the Linkerd Slack.
Absolutely. They definitely should do that. And of course, we have a follow-on. What do I think about ambient mesh? Most of what I said about Cilium applies equally to ambient. It's very new. It's more operationally complex. So it's much, much harder to talk about it being mature and easy to use and things like that. Yeah. And yeah, we may or may not have written articles a few times that pretty much boil down to, no, really, sidecars are much simpler to work with and much simpler to reason about. Just use the sidecars. Make sure you use a sidecar that's light enough and that's lightweight enough that you don't have to worry about its resource consumption. And coincidentally, we have such a sidecar right here at Linkerd.
Yeah.
Yeah.
Yep. So that's a pretty solid point.
Yeah, even the sidecarless, it's worth pointing out, even the sidecarless meshes still use proxies. They just do the proxy at the host level or the node level in Kubernetes. And that introduces some really interesting things and some really interesting complexities. But we've written a lot about that, so we don't need to rehash all of those right now, other than saying, yeah, go read the posts. They're informative. They're helpful.
Well, I think
We
we
hope.
also want to say thank you to everybody for watching. Really appreciate your time.
Absolutely.
Flynn, thank you for presenting. I found that really valuable. I
Cool.
think with that we're gonna wrap up.
Yep. Oh, one more thing. David here has commented, days worth of testing out all the things. It's entirely possible that I spent more than a day trying to test this while putting it all together. So yeah, love to hear how it goes for you. Thanks
All
much,
right, folks.
everybody. Really appreciate it.